Good morning, student. I hope you have understand all the terms which I have explained in the last class. Now let's learn the next point, which is metallurgy of the aluminium, which means the extraction of the aluminium. How we can extract the aluminium from the ores. Okay. So first and most important thing is you have to know the property of the aluminium. So the first and most important, that aluminium is a highly electropositive metal. Okay, in electrometals, in series we already learn that the most reactive metal series, so that reactivity also is high. So the reactivity of aluminium is more. Okay, so it is not present in free state. Okay, so this 3 point you have to know about this aluminium, which will useful to understand this process. Okay, so first important, the aluminium is a highly electropositive metal. Second, the reactivity of aluminium is more, so it is not present in a free state. Okay, now for the extraction of the aluminium, in your textbook it is given there are 4 ores, that bauxite, corundum, cryolite and aluminite. But the nowadays you know that the aluminium is a first element which are first number element which are abundant in the highest abundant in earth crust nowadays. So from the bauxite we are extracting aluminium, and it is very useful metal though. That's why this extraction of the aluminium is very important for exam point of view also, and useful also. Okay, so the extraction from the bauxite. So the Al2O3 twice H2O, this is bauxite. From the bauxite we are extracting the aluminium. So the concentrate here, student, the numbers of question will come in this point. Very important point for exam point of view. Very important. Some short question also will come. So I am explaining during this class that which type of question will come. Okay, now in bauxite there are few impurity are present, like a sand, some impurity like a sand, iron, or we can say Fe or Sn. This type of impurity present in the bauxite. Okay, so first what we'll do, as we learn in a last time some steps to concentrate concentrated or to find out the ore. So these terms we already learn. Okay, that ore first dressing we have to do, then concentration and convert into the oxide, and after the convert into the oxide, convert into the we have to reduce, and we can able to find out the pure metal. Okay, so we have to go through all this process to extract this aluminium. Okay, so the first step, what is the first step? First step is a dressing of the ore. You concentrate here, after explanation of mine you can read from your textbook. Okay, so first concentrate here, student, listen carefully very well. So step number 1, a dressing of the ore. Now what is the dressing? Dressing, which means that we learn the dressing, that hand picking, grinding, crushing, pulverizing. So first what we'll do, we have a bauxite ore. That bauxite ore first we crush it and the pulverize it, which means that we have to make in a powder form. So that is a pulverizing. So that first dressing we have to do. So dressing is a crushing and pulverizing. Okay, now in the during this pulverizing we can able to remove the, if the iron impurity is there. So if we know the iron impurity is there, so the little amount of the iron impurity also removed by the electromagnetic process. Electromagnetic process, which means that the belt which have a magnet wheel. Okay, we learn in last period. So that wheel is there, and through that also we can remove the little amount of the iron impurity. We can remove, not full all amount, completely we cannot able to remove by this, but a few little amount of the iron we can remove by this. Okay, so that is a dressing of the air, dressing of the ore. Okay, now after the dressing we have to convert in the concentrate. Okay, the step number 2, the concentration or the purification. Concentration and the purification. So there are 2 methods for the concentration and the purification, that is a Hell's process and the Bayer process. Hell process and the Bayer process. So first we learn the Hell's process. What is the Hell process. So in health process of step number 1, there are 3 steps. Both the process are present in a 3 steps. So I will explain turn by turn. First I am explaining the health process. What is the meaning of health process? What he has done to concentrate the ore. Okay, concentrate ore. Now the step number 1, the bauxite ore. Now the after the concentrated, after the pulverizing, making powder form. So first this bauxite powder dissolve into the sodium carbonate Na2CO3 and heat it. When it dissolve, it convert into when it heated, the aluminum is convert into the sodium meta-aluminate. This is the sodium meta-aluminate. So sodium meta-aluminate solid when dissolve in it, so it convert into the sodium. We have to heat it. Okay, for some time we have to heat this solution. So the carbon dioxide and water is evaporate. This is a gaseous form also, which will be evaporate, and in precipitate form the sodium meta-aluminum is present in a precipitate form, and the very big precipitate will come, because it is not on small scale. It a very big scale. In a industry, the very big vessels are there. So in the big vessels this procedure is happening. So the very big particles of the sodium meta-aluminum are coming. So that particles, first what we'll do, we first need to pulverize one more time it. So the pulverize, which means we convert into the small particle, or we convert into the powder form. So when we get this sodium meta-aluminate, that convert one more time into the powder form, and then that powder form, in step number 3, what is the happening? In this sodium pulverized mass is dissolved into the water, and this carbon dioxide also, little bit carbon dioxide is added in it. The carbon dioxide pass through it. Okay, no doubt here it is coming, but they are evaporate. Here the water and the carbon dioxide is coming, but they are in gaseous form, and we can collect that, or we can this will be removed. Now what, first we'll take the sodium meta-aluminate. This sodium meta-aluminate dissolve into the water, and that after the dissolving it, if we pass the carbon dioxide through it, through the solution, so it sodium bicarbonate will form, which means this sodium is take out, and now this substance is form a aluminium hydroxide, AlOH3, and which is coming as a precipitate form, and this is a solution. This form as a solution form, which means the solvent, we can say solvent, and here these are the precipitate. Okay, PPT I am writing, which means that precipitate. Have you understand this? What the first step, the bauxite powder react with the sodium carbonate, heat it. When it convert into the sodium meta-aluminate, that sodium meta-aluminate one more time the pulverize, and when the sodium meta-aluminate dissolve into the water and pass the carbon dioxide, immediately this sodium is react with the carbon dioxide and form a solution, sodium carbonate, and that sodium carbonate also we can reuse. We can reuse this sodium carbonate in this step. Okay, and which is convert into the, here the product we will get the aluminum hydroxide, very precipitate we are getting. Okay, that precipitate will take out, and with that precipitate, when dry it, after the dry it, what we'll do, we'll heat it at very high temperature, or we can say that ignite. Okay, we can say that we ignite aluminum hydroxide. Okay, this aluminum hydroxide is ignite at 1100 degree centigrade temperature, or 1000, we can say 1000 or 1100 degree centigrade, and we will get the pure alumina, Al2O3, pure alumina we will get, plus water, which is a vapor form and which will evaporate. Okay, I hope you understand this first, second and third step. Okay, this is the health process. He used sodium carbonate. Okay, he used sodium carbonate. Here the sodium carbonate convert into the sodium meta-aluminate, and sodium meta-aluminate one more time react with the water and carbon dioxide, it convert into the aluminum hydroxide, and this aluminum hydroxide, when we ignite at 1100 degree centigrade temperature, it will convert into the Al2O3, which is called a pure alumina. Okay, and this water will evaporate. You need to remember this point. Okay, now let's learn the Bayer process. Now what is the Bayer process first? In this Bayer process, first we'll take a step number 1. Now this scientist, the Bayer, he used the this powder form of the bauxite, used a concentrated NaOH. Now this concentrated NaOH can able to dissolve this aluminum bauxite powder. Okay, this concentrated NaOH can able to dissolve this bauxite powder. Okay, and when we dissolve it, the impurity present, which means that the sand cannot able to dissolve into the NaOH, so sand remain as it is. Okay, then the other impurity, iron also not able to dissolve into the NaOH, so this impurity we can able to remove by at this step. At very first step, we can able to remove this sand and iron by dissolving Al2O3 dot twice H4, which means bauxite. If we dissolve into the water, dissolve into the NaOH, then immediately a bauxite can able to dissolve in it, but the impurity which is present in it, which is a sand and iron, cannot able to dissolve, so it remain as it is as a precipitate form. Okay, as a solid form. So now when we heat this solution at 150 degree centigrade or 200 degree centigrade temperature, we will get the sodium meta-aluminate, which is a soluble, or we can say which is present as a filtrate form. Okay, what is the precipitate form? The sand particles and the iron particle, which are the impurity present in it, which are present as a solid form, and we can filtrate out. Okay, we can filtrate out this solution, and the sand and iron can able to remove as a solid form, and the filtrate which is present in it, that filtrate is a filtrate form. Okay, so that is a 2Na sodium meta-aluminate, which is a present in the filtrate. Okay, you know what is the filtrate. Okay, when the solution have a solid particle and the liquid particle, so when we filter out the solid particle, we can able to take out, and the liquid we are getting, that liquid is known as a filtrate. So the sodium meta-aluminum present in a filtrate form. Okay, and Fe impurity can able to remove, which is insoluble in it. Now what we'll get, now we have a filtrate. Now second step, we have a filtrate of the sodium aluminate. Okay, sodium meta-aluminate filtrate we have. Now this filtrate is diluted with the water. This filtrate we are getting, that filtrate we diluted with the water and heat 50 degree centigrade. Why we diluted? We wash this sodium meta-aluminate, we are washing it. So we make a diluted at 50 degree centigrade temperature. So when we add water in it, so NaOH will come. Okay, and the aluminum hydroxide, AlOH thrice as a precipitate we can able to take out. So NaOH, that is we can reuse. This NaOH we reuse in a step number 1. So NaOH will coming out, and we can reuse this NaOH, and this AlOH thrice as precipitate is coming. Now this precipitate, when we heat it, the same method, just like this Bell's process, same way, what we have to do, step number 3, AlOH thrice, that we ignite it, and it convert into the pure alumina. It ignited and convert into the pure alumina, which is we will get, and water, gaseous form, vapor, which is take out. Okay, so what we'll get? A pure alumina, Al2O3. This is a concentration method. If you do not able to understand, see one more time this video, so you will get a particular idea about both the process. Here NaOH is taken, and here Na2CO3 is taken. You read it, this both the process in your textbook, it is given, so you can able to understand. Okay, now what we learn, where we reach. Here what we have done, the ore dressing we completed. Now concentration we completed, and concentration, the gravity process through concentration we completed. Now after a concentration, what is the process? The conversion of the ore into oxide. Okay, which conversion ore into the oxide. But here you can see that the ore already present in oxide form, Al2O3. Here also Al2O3, it is already present in oxide form. So this step, no need to do this step. Okay, so the ore to oxide ore, the step number 3, which is ore to convert into the oxide ore, which is already done. So no need to do this process. Okay, how you understand this? I hope you understand. Very important point for exam point of view, students. Sometime only Bayer process will ask, sometime help process will be asked in exam. So you need to write all these 3 steps. Got it? Okay, if you can't able to explain, then it's fine, but you have to write this equation also. The little bit amount, a little statement you can have to write which you were explaining, but here this 3 step for the both process you have to do. Okay, so step number 1 we have completed. Step number 1, dressing, convert into the powder, powder to concentrate, concentrate by 2 process, Hell's process and Bayer process, and the Hell process done with the sodium carbonate and the Bayer process done with the concentrated NaOH. Got it? Okay, I hope you understand this very well, student. Okay, now the next one will get oxide form. Okay, now what is we have done, completed. Now the oxide form will take. Now the next, the step number 4, what is the step number 4? The extraction of the metal from the concentrated ore. So the extraction what we have to do, here the oxide form is present, so we have to reduce by the suitable agent, coke, CO2 and H2O, etc. like suitable reducing agent through we have to extract. So what we can do now, here the next process here, pure alumina converting from the pure aluminum. This is the next process. But as we know that Al2O3, the aluminum is a very reactive. Aluminum is a very reactive metal, as I told you before. So it is very reactive. That's why this react with the oxygen and form oxide, which is a very stable compound. Al2O3, because the aluminum Al is a very reactive, so when it react with the oxygen, so the bond formation, this is very strong bond formation, so the very strong bonded, so that is why this oxide is a very stable. So when we are doing the reduction reaction with the carbon, if we reaction with the carbon, the CO plus Al or carbon monoxide and CO2 plus Al, or hydrogen then Al2O plus Al. So this will not possible. This will not possible. Why? Because it is very stable oxide. So this reducing agent which is coke, carbon monoxide and hydrogen, which are reducing agent, cannot able to reduce aluminum oxide into the aluminum. So the reduction not possible with the carbon, CO2 and H2 to get alumina. So this process is not possible. That's why we are doing a Hell-Hérold process. Okay, why we are doing the electrolysis reduction process for Hell-Hérold process? Because of this reason. Because of this reason we are doing this process. Okay, you need to know about this. In short question, in reasoning question, why we are doing electrolysis reduction, why we are not doing this reaction? Because of the stable oxide. It is very stable oxide because the aluminum is a very reactive and a very strong bonded. So that's why this reducing agent cannot break this bond. So that's why we are doing the Hell-Hérold process through the reduction with the electrolysis process. Okay, now the electrolysis process, as we in 9th standard we learn little bit about the electrolysis process, that here the cell is given, 2 plates are given, one of the behave as a cathode, one of the behave as an anode, and the on cathode the one of the particular element on cathode the particular element will come liberated, on anode particular element will liberate. Okay, so suppose this is a anode and this is a cathode. Suppose this is anode and this is cathode. So on anode always anode have a positive charge and cathode is a negative charge. So the anode is a positive charge and cathode is a negative charge. So whenever the ions are coming through this anode, so this positive charge, the negative ion coming through the coming on the anode and positive ion coming on a cathode. Okay, so which means that Al2O3, so the oxygen, here the oxygen liberated on anode and Al liberated on cathode. This process is an electrolysis process, right? But what is the problem is that we have to convert this Al2O3 in a molten state. Then only the electric current can able to pass. This is the, we have a molten state. solid state we cannot able to pass the electric current. Okay, so what is the problem? Before we understand the process, you have to understand the process. First process, problem. What are the problem arise? The aluminum O3, when we want a molten state. So for the making of the molten of the alumina, what temperature? 2050 degrees centigrade temperature is required to make a molten state of the alumina. Got it? So but very high temperature and we mold it, but at this temperature the alumina form a vapor. So at this temperature the aluminum convert into the vapor. So at this temperature the alumina vaporize. So that is the first problem. And because if we molten state, if we take the alumina or the molten state, if we find out the molten state, but it is a bad conductor of electricity, or we can say non-electrolyte, and also the very big energy, also the energy also loses, very high energy of we are losing, because it convert into some of the aluminum vaporize, and the very few amount of the aluminum present in the molten state, and that molten state is a bad conductor of electricity. Okay, so this problem are arising if we do like this. So what is the solution? Solution is that we are adding in the alumina we are adding a cryolite and fluorspar. Cryolite Na2Al(F6) and the fluorspar CaF2 we are adding in it. Now what they are doing in this alumina? So the first, the cryolite, very important, in short question it will come. In short question it will come. Pay attention here, very important student. Cryolite we are adding, Na2Al(F6) cryolite is adding. What happened when we add cryolite? It lowered the melting point of the alumina 950 degrees centigrade, which means that we require 2050 degrees centigrade. So cryolite is directly reduce the temperature, which is a 950 degrees centigrade. That's why we are adding cryolite. Second point, it is also good electrolytes. So the two problems solved, problem number 1 and problem number 2. Two problems solved after adding cryolite. Okay, so what is it? Lowest the, so energy, this energy lose also we, problem number 3 also we reduce, because the lower energy require 950 degrees centigrade temperature and the good electrolyte. And what of fluorspar CaF2, what is done? It increase the conductivity. It increase the conductivity. Why increase the conductivity? As we know that the calcium is a small ion and the fluorine also the smaller. Compared to the other, calcium and the fluorine are a smaller ion, so they can move very fast. So the cryolite can increase the conductivity. We know that what is the conductivity? The current pass through this electrolyte, current pass through the solution of this cell. Okay, so that is a called a conductivity. So this ion which move faster from one place to another, so they can conduct electricity more. So the cryolite which have a calcium and ion fluorine which are very small in size, so they can move very fast, so that's why they can increase the conductivity. And also it is a good solvent, which means that alumina can easily dissolve into the fluorspar. So it is a good solvent. So this two thing we are adding to make a electrolysis process for a reducing of the aluminum from Al to O3, okay. So now process we will learn in a next class. Till here you read from your textbook, and if you find any query, then after this video you can ask me in class. Okay, thank you.